Okay, here's number 4, kids. Now, I gave you some data, and this is an ICE chart, and ICE stands for initial, change, and end. So starting, what happens, and then what do you have when the dust clears? And these are all in grams. This is number 4. So we have 1 gram of zinc, 1 gram of iodine, and before the reaction starts we have 0. And I showed you that you lost 0.25 grams of this, we lost all 1 gram of this, and we gained 1.25 grams of this. In the end, 0 plus 1.25 is 1.25. Most of you did this nicely. Over here, 1 minus 1 is 0, and 1 minus 0.25 is 0.75. And this really mirrors our experiment in that after the reaction, we ended up with a test tube with a bunch of metal we figured out was zinc left over. We had no more iodine because it wasn't that brown color. And we had a clear solution that once we added a little bit of fire, we ended up with a white powder, and it weighed about 1.25 grams. Actually, in your experiment, it was about 2.5 grams, and this was about 1.50. So it's just everything times 2. And what this really tells us is that, one, that all the iodine got eaten up first, and we had leftover zinc, so that iodine is a limiting reactant. It also tells us that, look, the total of the mass here is 2 grams. Over here, that's 2 grams, so that none of the mass was lost, it was just reshuffled. So we know that we can conjecture that maybe the zinc iodide, this compound, is made up of the iodine that we lost and some of the zinc we lost, but in a different form because it looks different. But the mass argument can really tell us that something has happened here and here. What it also shows us is that 1 plus 1 doesn't equal 2, that they stick together in a way that's not just adding masses together. It's not just adding things together, it's adding a certain number of things together. So hopefully that helps. Yeah, the real explanation is in the next one, which we'll do in just a second.